So we are now going to implement the main functionality that will handle a video compression. We'll start by creating an API that will send a post request to the backend. So the API will handle all our responses or errors, including abort signals, and finally returns the compressed video data. After that, we'll then create a method called handle compression, which will be in charge of the main video compression flow. This particular method will be in charge of validating the selected file to make sure that it exists. It will also generate a job ID and will also create the abort controller. The method will be in charge of setting the loading state of the UI and also converting stored file data into file objects. The method we call the API that we have implemented for compressing video with form data, which will comprise of the file name and the job ID. The method will also be in charge of handling a successful video compression by updating the progress to 100% or showing errors and finally cleaning up the states unless cancellation was requested. We are also going to create some helper functionalities, such as a functionality for generating a job ID, which will create a unique ID for tracking a compression job. We're also going to have a functionality for setting loading states, which will be responsible for toggling a UI element during loading. We'll also have another functionality for converting stored data in the form of array buffer into file objects. We will also have another functionality for handling the progress update in real time. So this functionality will handle the progress bar update and all messages. It will also handle the completion and cancellation UI. We will also need to implement a functionality for showing the cancellation UI. So it will display cancellation screen with the file info. So when you cancel a video that is being compressed, there should be a UI that will display the information of that video you just canceled, like the video name, the size. All right. So we'll also have a functionality that will hide all elements for cancellation states, and we'll have a functionality that handles all cleanup after cancellation, because when we cancel a video that is being compressed, we would need to clean up some of the resources that we use during the process. All right, so we don't want to have any leftover, so we need to clean everything properly. So then we also have a functionality that resets compression related states. So we need to reset the UI. Sometimes when we refresh, all right, maybe after a compression process, we need to like refresh the whole process. So we want to refresh the UI. So this functionality will be in charge of doing that. And then we also have a functionality that displays success metrics like the file path and size reduction. When we are done with the compression process, we would want to display the video that has been compressed, like the original size versus the compressed size. All right. I also want to display the file name and every other important details related to that file. Now, finally, we will need to implement a functionality that configures the UI elements for completion states. These are the next set of implementations we are going to cover right now. All right, so let's proceed with them. so we are done with those implementation. Let's quickly summarize what we have just implemented. Now, when a user initiates a compression process by clicking the compress button, this method, which we called a handle compression, is immediately triggered, all right, and it starts the compression process. Now, the video file is immediately prepared and sent to the server via our compressed video API that we just created. During video processing, the loading state shows the spinner and hides the compress button. When the video is being compressed, you only see the loading spinner as it is spinning. So now the compress button will no longer be active because a video is already being compressed. So there is no point for that compression button to be active. So we are going to make it inactive. Now the progress bar will immediately appear because by default the progress bar will not be visible. But when you start a compression process, the progress bar immediately appears, all right, and it will start to update with real-time data being sent from the server. When a video is being compressed, real-time data will be sent from the server via WebSockets. So when the data is being sent, we are going to be using that data to be constructing our progress bar in the front end. Now, when the compression is completed, if the process is successful, the file saving comparison is displayed because we want to display the before and after of the file, like in terms of the size, all right? So that is what will happen if the video is successfully compressed. But if the user cancels the compression process midway, the cancellation UI will display, all right, showing the name of the file and the size of the file. Now, we have also ensured that states are properly cleaned up regardless of the video compression outcome. Now, we need to handle the compression cancellation process now, all right? So we would create a functionality that will allow a user to cancel a video compression process at will. So when a video is being compressed, a user should have the opportunity or the ability to actually cancel the video if it does not want to continue with the cancellation process. So we are going to start by creating an API that sends a post request to the server to cancel a compression job by the ID. Now the API will handle all the necessary responses from the server and throw an error if the cancellation fails, and also finally return a JSON response if the operation is successful. After that, we will then create a method in the compressor.js file that will handle a cancellation request. So the method will first check if there is an active compression job through the state service, because remember that each time we select a file for compression, we are saving that file in the state service, all right? So now this method we want to check if there is an active compression job through the state service. It will now set the cancellation flag in the state service and update the UI. The method will also call the abort controller to terminate the ongoing compression process on the client side. So when the termination has happened in the client side, a request will then be made to the server to cancel the requested compression process. Now, if there is an error, the method will handle it and also revert the UI state if cancellation fails. So the abort controller will play a crucial role of providing a way to programmatically abort the compression process. So having said this, let's dive into the implementation. we need to implement another functionality that will completely reset the application UI and state to its initial or default state when the page reloads, or when a compression process is completed, all right, or when a user cancels a compression process. So we would want to reset the application to the initial state. Now, the method is going to call our state service.reset, or to clear all application state data. So this is to ensure uniformity, to ensure that everything is cleared in every state. And it is also going to clear and reset all input. It will also hide all cancellation related UI elements, success messages, and then display the default message, no file selected. It is also going to also ensure that the compress button is hidden, just the way the application is in the default state. In summary, this functionality will return the application to its fresh startup appearance, making it ready for a new file selection and operation. Now, let's quickly implement this functionality. So we are going to create an event handler.js file. This file will contain one main method called a setup event listener. And as the name implies, the setup event listener method will set up all the event listeners required for the video compression workflow. It will connect all the UI interactions to their corresponding logic. It will also act as a central hub for user interactions, ensuring that button clicks, drag and drop actions, and file selections trigger the appropriate compression related functions. Here are some of the event listeners that we are going to have and their roles. We are going to have an event listener that triggers when a file is selected via the file dialog. We are also going to have an event listener that opens the file dialog when clicking the upload area. We are going to have an event listener that allows users to drag and drop files into the upload zone. We are then going to have an event listener that starts a compression when clicked. We are going to have an event listener that attempts to cancel an ongoing compression. We are also going to have an event listener that resets the UI and all states in order to allow a new compression job. Now, this event listener file is going to control how users interact with the app, starting from file selection to compression and cancellation. It is also going to link all buttons and drag and drop actions to functions that handle compression, cancellation, and resets. Managing event listeners in one place will help to maintain a well-structured and predictable user experience. In summary, we want to ensure that all functionalities and event clicks are handled correctly from a centralized angle. Having said this, let's dive into the implementations. So now let's handle our WebSocket implementation. Our goal here is to be able to handle a real-time tracking of a video compression progress update from the server. Just like I've said already before, we want to be able to track the video compression process, all right? So if a user selects a video file to be compressed, it is important to me that we give the user the opportunity to know the video duration, like how long the compression process is going to take. All right, so and we are going to be giving the users this information via a percentage approach. Like the user should be able to see the progress bar updating and updating in real time. This is something that WebSocket is going to do for us. So WebSocket is going to be sending those details from the backend, and we are going to use those details that is being sent from the backend to build the progress bar. All right, so because we want everything to happen in real time. Now we are going to create a key functionality which we are going to call connect WebSocket, and the method will accept the handle compression method as an argument. Sorry. And also, if you remember, we already implemented the handle compression method in our compressor.js file. All right. So that method will be in charge of handling a video compression process. So that is what the argument that this our WebSocket functionality is going to take. It will check if a connection already exists before connecting. All right. So it will also use sub.js to connect to our backend endpoint for WebSocket, which is localhost 5050/progress, and it will then subscribe to /topic/update progress to receive progress updates. If you check our controller in the backend, that is what we specified. That is the part we specify, which is /topic/update progress for receiving progress updates in real time. So incoming messages are going to be forwarded to the handle compression method, and errors are also going to be properly handled, and there will also be an automatic reconnection after a 5 seconds delay. That is if if there's an issue with the WebSocket connection, all right, or if it disconnects. So there will always be automatic reconnection after every 5 seconds delay. So we will also implement a disconnect WebSocket functionality, which will safely deactivate the Storm client and ensure proper cleanup. So let's dive into the functionality. Now, having completed all the implementation, it is time for us to initialize the app. We are going to create a method called init app, alright? So the method will have the responsibility of setting up the application when the DOM loads. The method will first initialize the state service, which manages all states in the app, such as storing the job ID, cancellation status, etc. Remember that we are going to be saving most of these values in the state service in order to maintain consistency across our application. Then the next thing we are going to do, when this method is initialized, it is going to reset the UI to a clean state, all right? And then it will then connect to WebSocket for real-time progress updates. And finally, the method will set up all the event listeners. Now, all this is to ensure that the app starts with a clean state and proper WebSocket connection. So let's quickly implement this method. Alright, so this brings us to the end of part 4, where we officially brought our video compression app to life on the front end. Presently, we have built a complete full stack application. We started from setting up real-time WebSocket communication, handling secure uploads, integrating FFmpeg, managing background tasks, all the way to building a smooth, responsive UI with drag and drop support, and also progress tracking and task cancellation with state management. This has been quite a journey. So first and foremost, I want to say a big thank you to every single one of you who followed along, liked, commented, subscribed, and shared this series. If you made it all the way from part 1 to part 4, congratulations. You have just built a real-world full-stack applications from scratch. In part 5, we will review and test the app end-to-end. We will also make all the necessary corrections if we encounter any error or during the test process. Please hit that like button if you found this video helpful, and don't forget to subscribe and turn on the notification bell so that you will never miss a new upload. Drop a comment below and let me know what part of the project excited you the most. I would also love to know what you have learned so far from this project. Watch out for part 5. Stay tuned and keep building.